Good morning to all. Now we'll start the webinar. I welcome HOD ma'am, Department of Computer Science and Engineering, Dr. B. Amutha ma'am, to welcome our chief guest.
A very good morning to all of you present here. This is our privilege to have Mr. Jason Mays, Senior Developer, Advocate for TensorFlow, Research and Machine Intelligence at Google. So I welcome you, sir. And this is our privilege, actually. And most of our faculty members, research scholars, UG students, and PG students are having a passion to learn machine learning with TensorFlow, also Keras and other machine learning stuff, because we are having a BTech program, especially in artificial intelligence. Also, we are running one more BTech program with a CSC specialization with artificial intelligence and machine learning techniques. So it is a need of the hour that all of us must know about what is happening, what is the stuff in machine learning, and what TensorFlow is. So this is the time that you can elaborate on the machine learning with the TensorFlow to all our audience. Again, I extend my warm welcome to Mr. Jason Mays and the audience so that they can get the benefit out of it. Thank you.
Cool. Thank you very much for having me today. It's exciting to be here presenting to you all. So yes, if you want me to get started, I can do that now. And we can share my presentation screen if that's good. Is someone sharing my screen?
Yes, sir. Good morning, sir.
Hi.
Welcome the speaker. Good morning to all. Mr. Jason Mays is a web engineer at Google. He is also a hybrid web developer, programmer, technical consultant, and analyst with a creative twist who loves to innovate, inspire, and simplify solutions. He is currently working at Google in a team known as Creative Innovation, helping to develop bespoke technical web solutions for Google's largest clients and internal teams globally. He typically works on projects that never been made standardized before to deliver a scalable solution using Google infrastructure, best practices utilizing the latest web technologies such as HTML5, CSS3, JavaScript, and in short, they often attempt to make what is considered infeasible to do in-house at other companies possible. As part of his 20% time at Google, he has also been a mentor at Google campus since April 2012, where he advised and helped high-tech startups in London. I welcome the speaker to start the session. Thank you, sir.
Cool. Thank you very much. So hello, everyone. My name's Jason Mays. I am the Senior Developer Advocate for TensorFlow.js here at Google. And of course, today we're going to go through what TensorFlow.js is and why we want to use it, of course, in JavaScript in the web browser. So without further ado, let's get started. Now, I get asked a lot about my career history to date, actually, and I think some of that was actually summarized in the opening speech there. And just for context here, in case any of you are interested, this is essentially my path to date. You can see that I studied at the University of Bristol as a computer scientist, getting my Master's of Engineering back many, many years ago now. And after this, I became a web engineer at various startups in England. And it's here I decided to refine my skills to become a full stack web engineer doing both front end, back end, design, and UX. And that's when I got my first job at Google as a web engineer with them. And this allowed me to then progress into creative engineering, where I used those skills that allowed me to make pretty much anything I wanted, from front end to back end and everything in between, to prototype world first for our top 100 or so customers globally. And you can see some of the projects I've worked on in the past on this slide. And now finally, I am a developer advocate for TensorFlow.js, essentially combining my love for machine learning and my love for web engineering together into one role. But if there's one thing you take from this slide, essentially, I spent 16 years of my life fiddling with JavaScript, and it's obviously my favorite language to prototype in, and I hope to share with you today why those reasons are. Now, the first question you might be asking is, why would you want to do machine learning in JavaScript? And that is a great question. And essentially, it allows you to use JavaScript in almost any environment on the browser, server-side, desktop, mobile, and even Internet of Things. And if we dive into each one of those stacks a little more, you can see how we can run in many of the places we are very familiar with already. The popular web browsers there on the left-hand side, server-side via Node.js. We can go mobile native apps with React Native, desktop native with Electron, and of course, on Internet of Things, we can use Raspberry Pi via Node.js. And the key thing to note here is that JavaScript is one of the only languages that can run across all of these environments without any additional add-ons or plugins, and so on and so forth. So just for that reason alone, it's actually a very, very powerful language. And with TensorFlow.js, we can retrain via transfer learning, and we can write our own machine learning models completely from scratch if we choose to do so, just like you might be familiar with Python already, but in JavaScript. And with that, we can then pretty much make up anything we might dream up, from augmented reality, sound recognition, sentiment analysis, conversational AI, and much, much more, whatever you might dream up. So there's 3 ways you can use TensorFlow.js. I'm going to go through those today with you. And the first one is to use our pre-trained models. Now, these are really easy to use JavaScript classes for many common use cases, as we'll see on the next slide. You can see here just a few of the models that we have available. We've actually got many more available on our website for you to check out. But things like object detection, body segmentation, so understanding what pixels of an image belong to the human bodies, pose estimation to understand where the skeleton of each body might be, things like face tracking and hand pose estimation, and even some advanced natural language processing, such as the BERT Q&A model. And we're going to dive into some of these so you can see these in action and get a feel for them. So the first one I want to talk to you about is object recognition. Now, this is actually using a model called Cocoa SSD behind the scenes, and it's been pre-trained to recognize 90 common object classes, like the dogs you see on the right-hand side. And you can see here, in addition to knowing that there are 2 dogs in the image, we get their precise bounding box coordinates as well, which allows us to draw these rectangles around them. So this is obviously different to image classification, which would tell us that a dog exists in the image, but it wouldn't tell us how many or where. So object recognition is a little bit more advanced and gives us a lot of interesting stuff to play with. And of course, we want to see this in action. So let me just switch over to my live demo here, and you can see this web page that I've actually created that is using the Cocoa SSD model I just spoke about. Now, if I click on one of these images live on the web page, you can see I can get real-time classifications of the objects contained within it. And you can see here, this dog is near to this cup and bowl of treats. So, you can imagine how you could use something like this very easily to detect if your dog is in the kitchen near the food or something like this and send yourself an alert. With JavaScript, this is very easy to do in just a few lines of code. And even further, we can actually go further than just images, and we can actually attach to the webcam as well. And you can see me live right now talking to you all, and it's able to classify in real time with a high frames per second the bounding box around me. And I think it's predicting me 90% confident that I am a person, which is always good to see. Now, the key thing to note here, of course, is that because this is running in the web browser in JavaScript, my privacy is completely preserved because none of the images coming from my webcam are actually being sent to the server for classification. It's all happening locally on my client machine. And that's really important in today's world where privacy is top of mind, or maybe you need to run it offline where you don't want to be able to talk to the server because you're in the middle of a field. And with JavaScript and progressive web apps, these kinds of technologies, this allows you to do that with ease. So that's the Cocoa SSD model, but let me go back to the presentation for a second to see some more. Now, the next model I want to show you is Face Mesh. This is just 3 megabytes in size, and it can recognize 468 facial landmarks, as you can see on the left-hand side. And it can do all of this upon multiple faces at the same time. And this can unlock some really powerful stuff in terms of augmented reality or whatever you want to do. And in fact, we're starting to see some business use cases for this already. Now, Modiface, who's part of the L'Oreal group, have used this for virtual makeup AR try-on. And you can see an example of this on the right-hand side of the screen. Now, the important thing to note here is that this lady is not wearing any lipstick. what's happening is we're actually using our face mesh model combined with WebGL shaders to color in her lips with the style of lipstick that she's chosen at the bottom of one of those circles there. And she can swipe through the different shades and see what it looks like before she even has to buy it and try it on for real. So it's a very convenient way to do things, especially in the current times we're living, where people don't want to be sharing lipsticks or going into stores because it's not acceptable at the moment to do that. So very, very powerful. And let me just show you another demo of this in action, because it's really cool to see live. And once again, here I am live talking to you. And you can see here that it's identified my face very accurately. And as I am speaking, you can see the mouth moving and my eyes blinking and all this kind of stuff. Now, because this is JavaScript, JavaScript is really, really powerful in terms of visualization and 3D graphics and all this kind of stuff. So in addition to doing the machine learning, which we can see here on the left-hand side, you can actually see that I'm rendering a 3D point cloud using Three.js at the same time. And even though I'm live streaming to you right now, I'm doing the machine learning and I'm doing 3D graphics all at the same time, I'm still getting a very reasonable frames per second up here, close to 30 frames a second. And of course, I can change the environments we want the model to execute on, such as WebGL for the graphics card, WASM for WebAssembly, which is on the CPU, or we can just run on the CPU directly, which is the slowest form actually, but you want to choose WASM or WebGL, honestly, for the best performance. And if I wasn't live streaming and doing other things, I could probably get closer to 45 frames per second. But yeah, it's really cool. And with this, just imagine the things you could make. You could do things like face mask, you could do AR makeup try on, or other kind of interesting things, whatever you might dream up. So moving on to the next model, 1 second here. Oh, let's move that further off the screen. There we go. The next one I want to talk to you about is body segmentation. So this allows you to distinguish 24 body areas across multiple bodies all in real time. And this is hard for me to demo in my home right now, but you can see here from this animation how it works. And you can see the people walking around in the room, and we're able to segment the image successfully, and the different colors represent different parts of the body. Now, what's even cooler is we're able to get the pose estimation as well, this kind of bluish line contained within the body, to estimate, where their skeleton is essentially. And this can be very useful for gesture recognition, or even things like understanding if you're doing a certain yoga pose or some fitness workout. In fact, some of the people from our community in India have already made things like this to count the number of repetitions they're doing for their push-ups or something like this, and they can automatically count it digitally to then tell them when they've completed their session and that kind of stuff, or to tell them if they're doing the posture correctly. So lots of really fun stuff can be done with this model. And on that note, I want to just go through a few delightful things that I created in my spare time using the BodyPix model. And on the left-hand side here, you can see me walking around on my bed, but I'm being removed in real time, making myself invisible, like an invisibility cloak. But note that as I go in the bed still deforms in that middle image. And this is all being done in real time in the web browser in JavaScript. So that's important to note. And because of that, it means my privacy is preserved. None of these images are being sent to a server. And you can see there, I'm walking on the bed, and you get this really cool ghostly effect. Now, another thing I created on the right-hand side is the clothing size estimator, which I saw some people talking about at the beginning of the chat. And this allows me to estimate what size of clothing I need in under 15 seconds just by standing facing front towards the camera and then turning to my side. And then it will give me automatically if I should choose the small, medium, or large at checkout. And I don't know about you, but I'm really terrible at remembering what clothing size I am for all the different brands out there that seem to use different standards and measurements for what they consider to be a small, medium, or large. So with this, it allows me to check out with confidence that I'm going to pick the right thing and less likely to have to send it back and get a refund, which is always very convenient. And I encourage everyone listening today to think about problems that they have in their lives, because often my source of inspiration comes from problems I have in my life, and it typically means other people have the same problems as you. And if you can fix that, then I'm sure it'll be useful to many others as well. And this is a good example of that. Now, the other thing I want to point out here is that both of these demos were made in just a couple of days. The invisibility demo I made in 1 day, and the clothing size estimator was done in a weekend. So with our body pix model, which both of these use, you can really make some advanced things very, very quickly without having to write a new model from scratch, which can take weeks or months. And you can actually reuse our existing ones to make very advanced things that are actually useful. So do consider that. And we can go further, of course. Why not give ourselves superpowers like we see in the movies? And this guy, who really loves 3D graphics from our community, combined TensorFlow.js with WebGL shaders, along with our face mesh model that you just saw demoed on the previous slides. And with that information, he knows where the eyes and mouth are in 3 dimensions. And he's been able to produce these amazing laser-like effects in real time in the browser. And you can see how smooth that is working there. But we can go further than that even. We can combine with all the other emerging web technologies, things like WebXR for mixed reality. And now with JavaScript in the web browser, you can actually do mixed reality, placing things in your room, as you can see here. And this guy is using the body pix model to recognize people from magazines and bring them to life in his room, as you can see. And all of this is running on like a 2 or 3 year old Android mobile phone. So, even with these particle effects and everything else going on, he's still able to do this in real time. And then I thought, well, let's go one step further. If we add web real-time communication, or WebRTC for short, I can actually teleport myself anywhere in the world. And you can see here how I can segment myself from my bedroom. I can then transmit my segmentation over the internet to a remote device somewhere else in the world. And that person can then place me digitally in their house as if I really was there. And this was a super fun one to make. And once again, it came from the need of wanting to have a more meaningful conversation in the times where we're all stuck at home due to the COVID situation. And I made this to have a more meaningful conversation with my friends and family so they can feel like I really am with them. And it really does make a difference here. It's much more interesting versus just a rectangle of me on the screen. I'm actually kind of there. They can walk around me. They can hear me from the right angles and all this kind of stuff. So a really interesting concept to explore further. Now, the second way we can use TensorFlow.js is by transfer learning. And of course, once you've outgrown our pre-made models, or maybe you need to recognize some custom data, you, of course, need to modify things to do that. And we, of course, can retrain our existing models to work with your own data programmatically if you are proficient with TensorFlow and that kind of stuff. However, I want to show you 2 easier ways to do this using some graphical user interfaces that we've created. Now, the first one is Teachable Machine, and this allows you to do both the training and the inference all in the web browser on your own custom data. So let's go ahead and look at that live. And if you want to follow along, I encourage you all to bring up Teachable Machine website on your on your computer. Just go to teachablemachine.withgoogle.com. I'll give you a few seconds to do that if you want to follow along. And when you get there, you should be presented with a page that looks something like this. And you can see that we have the number of projects that we can create. We've got image project for object recognition. We've got audio project for sound recognition. And we've got pose projects for pose recognition. And all of these we can train with our own custom data. Now, I believe they're going to add more later, so stay tuned for that. But for now, we've got these 3 as demos. And today, we're going to do the image project. So go ahead and click on that. Now, the first thing you see is that we've got a number of classes on the left-hand side, and it's always good to give them something meaningful. So the first thing I'm going to recognize is myself. So I'm going to put my name there, but feel free to put your name if you're following along. And then the second thing, I'm just going to grab a deck of cards that I've got in my room right now. And once again, if you've got something in your room that you want to recognize, just grab that and call it as such. So grab a book, grab a mobile phone, or I don't know, whatever you want, just find something and label it as such. Now, if you had more than 2 classes, you could actually add another class if you wanted to recognize 3 different things. But for today's demo, we're just going to stick with 2 in the name of time. So the next thing we need to do is click on webcam for the first class and allow access to your webcam if it asks you. And you should then see a preview like this. Now, what we're going to do is we're going to click on this hold to record button to take a few sample images of our faces. And we want to get some variety. So like move your face around in different angles and locations of the screen so it has the best chance to understand what your face pixels actually are. And we're going to do that. And I'm just going to do this right now. I'll move my head around like this. There we go. Good. And I've got about 61 images, it seems, right there. So now we're going to repeat this with the second class. So click on the webcam button for the second class. And it's important to get roughly the same number of images. Otherwise, you're going to introduce a bias to your data set where you're going to have more of one over the other. And then the machine learning model will think that it's going to occur more than the other, and it will try and predict it more often. So try and get the same number of images. And now do the same thing with your secondary object. So I'm just going to try and get 60-something images of this as well. So let's try that now. Okay, so that's roughly correct, and that's good enough. So once we've got our imagery, we can now click on Train Model. And what's going to happen now is that the web browser, sorry, TensorFlow.js in the web browser is going to attempt to modify the top layers of the machine learning model such that it can distinguish the difference between these two pieces of training data. And you can see now it's already finished. In less than 30 seconds, it's actually managed to retrain the model. So super, super fast. And you can see it's currently predicting that for this live feed here, it's predicting a JSON, which is correct. I am the thing in the frame right now. Now, if I bring my deck of cards here, you can see it switches to cards. JSON, cards, JSON, cards. And look how fast that is. It's real-time performance, and we made the whole thing in less than 2 minutes. So anyone who's watching this right now can go home and try this out and make their own custom classification model just like this. And it's then up to you what you want to do with that. Maybe you could control a Raspberry Pi that controls your house door to automatically close when it's dark outside. You know, what do you want to recognize and what do you want to trigger is completely up to you. I encourage you all to get creative and share with me what you make, because I think a lot of things could be made just with this alone, and it's a lot of fun. And I guarantee the first time you recognize an object in this way, you feel like you've got superpowers yourself. And it's a lot of fun to play with. So do try that out. And of course, go check out the other models there too, such as the sound recognition and the pose recognition as well. So with that, I'm going to go back to the slides. 1 second. Whoops. Back to present there. 1 moment. My screen is not full screen, but let me refresh the slide. Something weird is going on here. 1 second. Okay, present. There we go, that's better. All right, so you can see Teachable Machine is great for prototyping, and I encourage you all to try that out. Now, if you were to go beyond the prototype and you actually want to do a more robust production model that maybe you're going to actually share with the world and it's going to be used for a real business use case, then in that case, you might have a lot more training data than 60 images of each object. You might have tens of thousands of images. And for that, Cloud AutoML is our recommendation here. And Cloud AutoML supports exporting to TensorFlow.js. And you can see here, someone's been trying to classify different types of flowers. So all they've done is they've uploaded lots of folders of different types of flowers to Google Cloud Storage on our cloud server. And then they can hit next, and they can choose if they want to have higher accuracy, a trade-off, or faster performance. And of course, in machine learning, you've always got this kind of trade-off between the two. And depending on your use case, it might be acceptable to have a higher latency, or maybe it's better to have a lower accuracy but faster prediction. So it depends what you want. You can click on whichever you like, and then of course you can set a budget and how long you want to train for, and it will go away and train, and it will try hundreds of different hyperparameters and different models to try and figure out which one is best for your data. And it'll do this all for you behind the scenes automatically. When after it's finished, it'll come back and you can then export to TensorFlow.js at the end, as you can see here. And this will allow you to download the model.json files that exist to then run successfully in the web browser. Now, you might be wondering, like, how hard is it to actually then take that model.json file and use it? And the answer is very simple. In fact, it's so simple, it fits on a single slide. And you can see here, I'm just going to walk you through the code. So at the top there, we've got the script tag for TensorFlow.js library. That's just importing the TensorFlow.js library at the very top. The second script tag is importing the AutoML library. So nothing fancy here, just plain old HTML. And then further down here, I've created a daisy image. That's just a JPEG, and it's just a random image of a daisy. And this is the thing I want to classify. This could be other forms. It could be data from the webcam. It could be something else. But for now, I've just got an image of a daisy. And then here's the actual code to do the classification. It's basically 3 lines of JavaScript inside of this function here. And the first thing we do is we call tf.automl.loadImageClassification, and we pass to it the model.json file that we would have downloaded from the previous step. And of course, this model.json file would be hosted somewhere on your web server, so you would just point to the location of that. In this current use case, of course, it just is going to be in the current folder. Now, we use the await keyword here because this is an asynchronous operation. It takes some time to load that model. It could be a few megabytes in size. And of course, that takes a non-trivial amount of time. So we use the await keyword to tell JavaScript to wait for that to finish loading before we continue sequentially down below. So once it's finished loading, it'll be assigned to this constant called model. And then we can use document.getElementById Daisy. And that's going to grab a reference to our Daisy image above. And we're going to store that reference in this constant called image. And then the third line is await model.classify image. So we're just passing the image we're going to classify to this function. And again, this is an asynchronous operation. Even though it might just take 10 milliseconds for a computer, that's a very long time. So we have to use the await keyword here again. And that will then return to us, to our predictions object, a JSON object that contains all the predictions it's found for that image we passed to it. And you can call model.classify repeatedly again and again and again. Once the model is loaded, you don't have to reload it every time. It's in memory. You can just call classify many times a second to then do that for webcam data. And that's how we managed to do it for webcams and so on and so forth too. And that's about it. That's all you need to do. And you can then do whatever you like. You can trigger some creative experience from that. So if you recognize something, you can then send yourself an alert, or you can control some robotics, or whatever you want to do. It's completely up to you what you do after that point. Now, the third way to use TensorFlow.js, of course, is to write your own code completely from scratch using our low-level APIs. And of course, for that would require a whole separate talk to go into that. So today, I'm going to focus on the superpowers and performance benefits that you get by using JavaScript, both in the browser and on the server side in Node.js. So you can see here that the TensorFlow.js has 2 APIs. There's the Layers API that's very similar to Keras. If any of you have used Keras or are currently using Keras, you will feel very at home with our Layers API. It's basically the same function signatures, but written in JavaScript. And we've also got the Ops API, which is the more mathematical, lower level API that does all the fun stuff like linear algebra and so on and so forth. So if you do need to get lower level, then that is there for you as well. You can see how these come together. We've got the models sitting upon the Layers API, models sitting upon the Layers API, which then sits itself upon the core or Ops API. Now, this lower level API understands how to talk to different environments, such as the client side. And by client side here, we mean things like the web browser. And then that web browser understands how to talk to different backends, such as the CPU, WebGL for graphics card acceleration, or WebAssembly for more advanced performance benefits on the CPU. And it will automatically detect what is available, and most of the time it will select the right one that is fastest to execute on. But as a developer, you can actually choose to force one or the other if you know one of them has a performance benefit for your particular model. And the same story is very similar on the server side as well, but instead we use Node.js, not vanilla JavaScript. And with Node.js, it talks to the same TensorFlow CPU and GPU bindings that Python does, because both Python and Node talk to the C++ API behind the scenes. And that means we have the same CUDA acceleration and the same AVX support as Python, which means our performance is pretty much exactly the same for inference. However, we can be faster than Python in certain use cases, as you'll see later in the slides. Now, if you are preferring to stay in Python for your machine learning development, that's completely fine. And you can actually take your Keras models and load them via the Layers API in Node.js if you want to do so. And you can do that without any kind of conversion. And if you have a saved model, you can load that via our Ops API in Node.js. And again, no conversion is required. You can use that directly in Node. And that's really cool if you're trying to integrate with a web engineering team who are probably using Node. That allows them to work much easier with your machine learning models by using it in the Node.js environment. And then, of course, if you have a saved model, but you want to run it on the client side in the web browser, so that's not the server side environment in Node, then you can use our command line converter. that will take a saved model and convert it to the model.json format that we need to run in the web browser. And then, of course, you can use it over in that environment as well. So let's look at performance then. You can see here, this is from MobileNet v2, and we've got examples on the CPU and, of course, on the GPU. And you can see here for TensorFlow Python, we have a inference time of 7.98 milliseconds. And for TensorFlow Node, we've got 8.81. So within margin of error, it's basically the same result, depending what the server was doing when these things were taken. So for inference, it's essentially the same. It's less than a millisecond between them. But what gets interesting is that if you have a lot of pre or post processing and you rewrite that in Node.js, you'll get the benefits of the just-in-time compiler of JavaScript, which is a unique feature of JavaScript that compiles things at runtime. And that can lead to significant performance benefits, as we'll see on the following slide. And you can see here, Hugging Face, who are very famous for natural language processing, converted their DistilBERT model implementation for the pre and post processing into Node.js. And they managed to see a 2 times end-to-end performance boost versus Python in this use case. So a pretty compelling stat to just convert over to Node on that alone, which is really awesome. Of course, your performance benefits will vary depending on your model architectures and how much pre and post processing that you have. But if you have a lot of pre and post processing, then you'll start to see the boost here, as we can see from Hugging Face. If you have a very light pre and post processing, then of course it'll be basically the same as Python because our inference times are pretty much exactly the same as Python. Now, looking towards the client side, here are 5 superpowers that you can get that are hard or impossible to achieve when you are running on the server side. Now, the first one we hinted at before was privacy. Because TensorFlow.js can run in the web browser, it runs on the client side, and that means any of the sensor data that you're classifying stays private with that user on their machine. It doesn't have to talk to a server. And in the modern world, if you're working on a legal application or a medical application, or maybe you're working in Europe with all the GDPR rules, privacy is a big thing right now. And with TensorFlow.js, you can get it for free. Second point is lower latency. Because there's no server involved for the classification, it means you don't have any round trip time from the client to server and back again. And of course, that can improve the number of frames per second for your real-time application by cutting out the server. Now, the third point, if you cut out the server for inference, then of course, lower costs can be achieved. You don't have to run a server with an expensive graphics card, lots of RAM, or lots of CPUs in the cloud. Instead, you can do all of that on the end user's device. And if you've got a reasonably popular website, maybe tens of thousands of users per month, you can save yourself maybe $60,000 per month in serving costs by just using a CDN to deliver the model, and that's it. See, the cost of bandwidth is much cheaper than the cost of hiring expensive processors and graphics cards. Fourth point, interactivity. JavaScript from its very first day has been designed for the presentation and display of information. And as such, the JavaScript ecosystem is very battle hardened for computer graphics and the data visualization and all this kind of stuff. We've got very rich libraries for this, which are far more advanced than other languages out there right now. And you saw from some of the demos earlier how easy it is to create things in days or even hours versus what might take a lot longer to do or replicate in other languages. And then the fifth point is the reach and scale. Anyone in the world can use your machine learning demo just by clicking a link. Now, this is not true if you're executing on the server side and you're trying to get that running for someone to try out, because first of all, they need to install Linux, then they'll have to install TensorFlow, and then they'll have to install the CUDA drivers, and then they'll have to go to your GitHub and clone your GitHub repository. And hopefully you have very good documentation that they understand. And then if all of that goes well, they might stand a chance of running your machine learning application. Now, I don't know about you, but I don't have time for that. So like, if someone just sends me to a website and I can see it working in action, that's much more of use to me and for others in the world who just want to try it out to see if it's useful to them or not. And that's a great way as researchers to kind of get feedback on your model. You might be able to find biases or bugs much faster because 10,000 people are trying it out in these really interesting edge cases instead of just 10 people from your research community. So do think about the reach and scale aspects here as well. Now, looking on the server side for Node.js, you can actually see we've got some benefits there too if you do want to run on the server side. So first thing is that we can use the TensorFlow saved model format without conversion. So if you do prefer to run in Python for your machine learning, we can take the output of that and run it in Node without any conversion, which is really nice if you're working with a web team. And then it allows you to run larger models than you can do on the client side, because obviously if your model is gigabytes in size, you're not going to want to push that down to a tiny mobile phone and use all of its memory up. So there are certain situations where you would want to stay on the server side. The third point is it allows you to code in one language. If you're already using JavaScript, being able to keep all your code in JavaScript is a really big win for maintainability. And currently 67.8% of developers use JavaScript in production already. And that's a very large percent of people. And this is from the Stack Overflow 2020 survey. So this is new data, and JavaScript is on the rise. Of course, there's a large NPM ecosystem, so lots of great modules for you to reuse. And then, of course, we spoke about the performance benefits. You've got the same C bindings as Python, so you've got the same performance for inference, but you get that just-in-time compiler boost if you're converting over the pre- and post-processing layers. So finally, I'm going to end with some resources for you to get started here. Essentially, if there's one slide you want to kind of screenshot, this is a good one. It's got all the links you need to get started. Our website there, TensorFlow.org/JS, has lots of documentation and useful stuff to kind of take your first steps. Do also check out our models directory there as well. I've shown you just 3 models today, but we've got many, many more for you to play with that are super easy to use over on our models link. We're completely open source. So of course, we're available on GitHub for pull requests if you have an idea that you want to submit to the project. And if you've got very technical questions, our Google group is a great place to ask them, as the team often monitors that as well. And then if you are looking to get started fast, I've also made some CodePen and Glitch boilerplate code to show you how to use some of our models to get started with like accessing the webcam and classifying images and that kind of stuff very quickly. So you can just fork that and then have a working starting point. And all of this is like a code editor that runs completely in the browser. So it's really easy to just kind of play with, experiment with, and make something very, very quickly. Now, if you want to go deeper, our recommended reading is this Deep Learning with JavaScript book by Manning Productions. It was written by some of the folk on my team. And essentially, it's got everything you need to get started, from going from the very beginnings of machine learning to being quite advanced. And of course, with that, I encourage you to check that out. So if anything left to say here is to come join the community. I've shown you just a few demos today. I can't fit them all in. We're getting new stuff every single week. And in fact, we've seen a lot of love from India. So keep that coming. If you check out the Made with TFJS hashtag, you'll see new stuff coming out every single week. And if you make something yourself, please do use the hashtag, as we would love to see what you're creating. And you might even win a chance to be on our future show and tells that go live to YouTube to hundreds of thousands of people. And of course, maybe even a write-up on our blog. So do share with us what you make for a chance to win that. So on that last note, what will you make? I want to leave you with one final piece of inspiration here. This guy from Tokyo in Japan, he's a dancer by day, but he's managed to use the TensorFlow.js BodyPix model to make this really cool hip-hop video. And the reason I end with this is because this really does prove that machine learning is for everyone. And I'm super excited to see how TensorFlow.js can enable that at scale for artists, musicians, creatives, and much, much more beyond just engineers and data scientists and researchers. And I think we're going to see a lot of interesting innovations coming out as these kinds of people start to push the boundaries of how machine learning models are used beyond the original creator's dreams. And I'm very excited to see what you will make. So do use that Made with TFJS hashtag if you have anything. And then with that, feel free to stay in touch. I'm happy to take some questions on the live chat right now, so feel free to ask over there. And I'm available on Twitter or LinkedIn if you don't get a chance to get your question answered today. So I'm always happy to talk over there as well. So feel free to add me and stay in touch. Thank you all for listening, and I'll hand back to the organizers. Thank you. So I'm just looking at the questions in the live chat. I'm just going to go through a few of these that I see. Does TF.js support TF federated? Great question. At the moment, it does not. But if that's something of interest, then we have started a special interest group, a SIG, as it's known, over on GitHub, to encourage the community to help us port over some of the work in the core TensorFlow into JS as well. So that's something that is of interest to a lot of people. Maybe you can find a hacking group to work with to help port that over. We are a small team. We've only been around for 3 years, so we're still growing. And of course, we do need the community's help to help port everything over, because there's a lot of stuff in the core TensorFlow that is still being ported over right now. But there's enough to get started, so do have a play. But it's going to grow with time. And as more JavaScript developers get on board, I'm sure we're going to see a lot more of that coming over and getting parity. I saw a question there. How can we work with you? Make stuff. If you use the hashtag, I'm probably going to find you online. And I know if you're working on a cool project, maybe there's some scope to hack together on something, let me know and we can see where that goes. So feel free to reach out to me on Twitter or LinkedIn if you have any questions about that.
Still it blank.
Let me see here. How about using Firebase ML Kit? Great question. So Firebase ML Kit is for native applications. That's not JavaScript. So TensorFlow.js is specifically for JavaScript developers. And with TensorFlow.js, of course, we can deploy to native via React Native. If you wanted to write native apps using TensorFlow.js, that would be our deploy path. ML Kit, of course, is more akin to TF Lite and that kind of stuff. So if you're looking to use TF Lite, then you can use all that Firebase stuff with that. However, I just launched a code lab on how to host TensorFlow.js models with Firebase hosting. So do check that out if you're interested in using TensorFlow.js with Firebase and that kind of stuff. And that's available on codelabs.withgoogle.com. Next question that I see, how to build intelligent IoT devices with TensorFlow Lite. Unfortunately, I am not a TensorFlow Lite advocate. I am the JavaScript advocate, so I don't know much about TensorFlow Lite. You'd have to ask someone on that team to get that question answered, unfortunately. So feel free to reach out to my equivalent in the TensorFlow Lite team. I'm sure there's someone who does this for them. Feel free to add any other questions you might have whilst I'm here in the live chat. I'll answer them as I see them. I'll give people a few more minutes because I know the live stream is slightly delayed versus my live speaking right now. So I'll just give them a few more minutes to ask any questions you might have. Is it possible to train TensorFlow.js node models using a remote platform? What do you mean by remote platform there? I mean, yes, you can use the cloud, and when we're using Node, we're typically executing in the cloud on like the Google Cloud Stack or something like this. So technically, it's possible for you to then point to something else and grab your training data from a different platform and then bring it in and train on it. So depending what you're trying to do there, it is technically possible to do something like that. How does BodyPix work in mobile? Obviously, on mobile phones, it's going to be slower. It very much depends on what device you're running on. We've seen some performance issues on the Pixel 3. I don't know why, but we're looking into that. But on the iPhone and other Android devices, it's been pretty decent. You can also change the configuration settings for BodyPix to sacrifice a bit of accuracy in order to get a higher frames per second. So I'd encourage you to check the documentation on our GitHub for BodyPix, and you can see the configuration object, which allows you to change how precise you want it to be, and that can really make the frames per second go up a lot more if you're using it in that kind of case.
Sir, excuse me, sir.
Yeah.
Some of the questions I have noted. Shall I give it to you, sir?
Sure. Yeah. If I've missed some, feel free to remind me. Yes, definitely.
Okay. First question by one student: which is better, OpenCV or TensorFlow.js?
That I don't think one is like better than the other. It's just more down to what you're used to using, and obviously. If you're comfortable using Python, then of course, go ahead and use OpenCV and other things. Nothing against that. But if you are a JavaScript developer or you're looking to get some of the benefits that I've mentioned in this presentation today, such as the privacy and such as the reach and scale of the web, then you might want to consider using TensorFlow.js in that kind of use case. So use the right tool for the job and the right use case. And yeah, I don't want to start wars between Python and JavaScript. I think both communities can actually work very nicely together and complement each other, in fact, by working together, in fact. So please do use the right one at the right time.
Thank you, sir.
Yeah.
Second one is object identification is applicable only for the dynamic objects.
Oh, sorry, say that again.
Is object identification is applicable only for the dynamic objects.
For dynamic objects, what do they mean by dynamic objects there? Sorry,
I
things
think
that are
they
changing,
will be
like
live or moving objects.
oh yes, but yes. So as you saw in the demos today, I was able to classify myself in real time with my webcam. So yes, it completely works in real time for that kind of stuff, and it's very fast actually. We get over 30 frames per second on a typical like MacBook Pro or something like this, maybe even more, 45 frames per second I've seen in some cases. So it's very good for real-time object classification, and of course is running all locally. So because we're not having to have that 100 millisecond delay going to the server and back again, that's how we can get that high frames per second. So yeah, it works great.
Thank you, sir. Third question, any technique to differentiate static and dynamic object detection?
So on the TensorFlow.js side, it just depends how many times you're calling model.classify, basically. So if you're doing a single image, you call model.classify once. If you're trying to classify the webcam stream, you're just calling it repeatedly in an endless loop. Once the previous classification has completed, you then call it again. And because it completes in 10 milliseconds or something like this, maybe 16 milliseconds, you're going to get like a very fast frames per second by doing that. So once the model's loaded, you just call model.classify again and again and again, and then you're good to go.
Yes, sir. Thank you, sir. Next question, what about TensorFlow Lite for using in mobile?
Yeah, I mean, if you prefer to deploy to the native applications with traditional like Android, Java kind of situation, then of course, TensorFlow Lite is a great option for you there. For TensorFlow.js, as I said, we only support React Native if you want to deploy to a native application. So if you prefer to use JavaScript, then React Native is your only choice. But if you want to use Java, not JavaScript, to deploy to Android, then of course you can use like TF Lite for that kind of stuff. Yeah.
Yes. Next, how does body pix work in mobile?
So I think I answered this one already before you asked me the question. So I think I've answered that one already. Thank you.
Okay,
Yeah.
sir. Next one, can TensorFlow.js use the underlying GPU of the environment I'm running on my backend?
Yeah. Yes. So if you're using TensorFlow.js in Node.js, which is on the server side, it will 100% utilize your GPU as long as you have the CUDA drivers installed, just like you have to for TensorFlow Python. TensorFlow Node and TensorFlow Python are talking to the same C++ API behind the scenes. So actually, they're exactly the same in the implementation under the hood. Now, when you're talking about TensorFlow.js in the web browser, that is a complete rewrite of TensorFlow, and that does not use CUDA. We actually use WebGL, which is our kind of 3D graphics engine for the web browser, in order to do the mathematics. It's quite a clever hack. They use textures and things to do the mathematics in the browser, and that gives us our graphics card performance in the browser. So it's not quite as good as CUDA, but it's good enough to get the frames per second that you've seen from the demos today, and that's good enough for real time for a lot of use cases.
Yes, sir. Thank you, sir. Next one, will TensorFlow.js work on React.js?
So we've got React Native and React in the web browser. Yes, I mean, as long as you can import JavaScript files and call JavaScript functions, then it's just like any other piece of JavaScript. So you can wrap your React stuff around that and do with that as you please. So yes, you can completely combine it with React or Angular or all these other frameworks and things. It's totally possible to do that.
Thank you, sir. Thank you very much, sir, for your patience to answer all the questions.
No problems.
Yes. Now I ask Kausigan sir to give the vote of thanks.
Good morning, sir.
Hi there. Thank you.
First of all, I thank our today's resource person, Mr. Jason Myers, who is a senior developer advocate for TensorFlow, research and machine intelligence at Google. It has been an excellent session, sir. It may be very useful for our students who are all studying artificial intelligence and machine learning. Overall, the session has been very excellent. Some of the topics like face recognition, body segmentation, web technologies, reachable mission, cloud auto ML. So these are the topics are very highlighted in this session. And
Yeah.
I express my sincere thanks to Dr. Revati Venkatraman, Chairperson, School of Computing, SRMIST, for providing an environment to conduct such an informative session. And I express my heartfelt thanks to our HOD Madam, Dr. B. Amuda, who encouraged us to conduct such a knowledgeable session and always been a backbone for conducting these type of events in our department. And I express my sincere thanks to Mr. Rajkumar, Assistant Professor, CSE Department, and Ms. Lavanya, Madam, Assistant Professor, CSE Department, who are all have been working in the background for making this event in a successful manner. And I express my sincere thanks to our final year student, Syed Anup Akhtar, who has been an initiator for this program. Overall, CSE department will express our thanks to that final year student. Overall, the session is in an excellent manner. So, and we as a department of CSE will be very happy for having this opportunity for listening such an informative session, sir. Thank you.
Awesome. Thank you very much for having me. It's been a pleasure. And thank you for everyone who tuned in today. I think we reached almost 300 live viewers. So thank you very much. And of course, feel free to share with your friends who didn't make it today as well. Always good to see others as well. Thank you very much.
Thank you so much.
Thank you, sir. Thank you very much for joining with us, and we had a wonderful
So
session, sir.
finally, we are at the end of the session.
Yes, sir. We hope we should be in touch in future for such a very good session, sir.
Yeah, sounds good. Hopefully I'll have some new presentations at some point. I've got a lot of work to do, but I'm hoping to do some new ones in the future for the coming year, of course, as well. So maybe doing some more advanced topics and going into more of the coding stuff and all this kind of thing. So excited for that.
Thank you, sir. Thank you very much for joining with us, sir. Thank you, sir.
No
And
problem.
from our department, there is a request to have some kind of collaboration project
Yes, sir, with
from
you.
Google. Yeah, any
Awesome.
small kind of project you can give the students, and students will give their work. Sir. It's a kind of
Awesome. Yeah.
training as well as yes.
Yeah, I'm sure we can figure something out at some point. So just feel free to email me, and we can talk about that.
Definitely, sir. We'll come back to you, sir. Thanks for your support always. Thank you, sir.
Cool. Thank you. Bye-bye.
Bye bye. Thank you. Thank you, guys. Bye.
Thank you, sir. Thank you, everyone. Thanks for everyone who have joined with us for this session. Wonderful session. Thanks for all the participants who have encouraged us. Thanks for support. Thank you.
So just wait for just 2 minutes. And I mean, I have posted that for attendance purpose.
Yes,
Okay,
I have
so
posted
students
the
are actually
feedback.
filling.
Please fill the feedback.
Yeah. So just a minute, and we will wind up the session.
Sure,
Thanks
sir.
for all the participants who have encouraged us. Thanks for all the support. Thank you.
Okay. So just wait for just 2 minutes. And I mean, I have posted that. Ma'am, still we have a queries no for the feedback form. Whether it is posted, ma'am?
Already I have posted, sir. It's there.
Yeah, I just post once again, ma'am. In that.
I'll do it again. I'll do it again.
Yeah, the people are waiting for that. Yeah.
Yes, I have. Now also
Feedback
again
form.
I have posted.
Yeah.
So kindly fill the feedback. I have posted it again. Thank
No,
you.
no, you just kindly post it in our, live, ma'am, Google Live. I mean the YouTube Live.
There
Yeah,
only,
YouTube Live.
yes, there only I
But
posted.
still we didn't get it.
I'm posting there only, sir.
Please check out, ma'am. 1 second. Because if you are posting, no, you'll be getting here also.
Not only numbers, those who are saying like present in the next class and
So kindly check the feedback form in Google, YouTube Live.
Rashmi.
Sir, Rajkumar, sir, I have posted the link to you also in the WhatsApp. Please, if possible,
Yeah,
you post
I'll be doing. No issues. Yeah.
In case of the way it could be.
it again.
Login for that is very good.
So from the School of Computing thing, I will be posting. Okay.
That will be better.
Yeah.
When you give presentation. Let it do. 390. Abstract presentation.
Sir, your mic is muted.
So from the School of Computing, I have posted that. Please, all of you, please check out.
Yes. Kindly fill the feedback link. Now it is posted on behalf of School of Computing. Thank you.
Probably next class you have to present. The Manoj Srivastava. You complete it. Manu. Note down the Manu. Kumar Rupam Raj. Abstract presentation.
Shall we wind up the session?
Yes, sir.
Kunal also next class request is
How the all others are not getting? Kindly check out the from the School of Computing post.
So the link is visible. I'm also seeing that.
Yeah, but how the people? You please go to the last end. Okay. I mean the
Check at the end. The link is available. Please fill the link.
just I posted. Yeah, ma'am. I think we done it.
Yes, sir.
Okay, shall we wind up then?
Yes, sir. We can wind up.
Okay.
318
Thank you. Thank
Thank
you
you.
all.
402. What is present?
So now the people are telling got it. Yes, good.
Sataj 402.